In this video, we're going to look at substitution for definite integrals. Now, this is something we use when we have more complicated integration, right? So say you walked into class one day and you had to solve this problem, the integral from 0 to pi of sine of x times cosine x with respect to x. You might already know that there's no such thing as a reverse product rule or a reverse quotient rule. It's not that simple when we're integrating. So this seems like a fairly difficult problem, but we can manipulate it and make it easier. Say we call sine of x something else, right? Because I see a relationship between sine and cosine. I know that cosine is the derivative of sine. So let's just call sine of x u, right? And this is where you may have heard of u substitution. It's because we tend to use the variable u. So u is equal to sine of x, right? I could say the derivative of u, so du is equal to cosine x dx. And that's exactly what we have in our original problem. We have sine of x and we have cosine x dx. So let's rewrite this, right? Let's rewrite this as the integral from 0 to pi of u du. And this is the exact same thing as we originally had because we said that u is equal to sine of x and du is equal to cosine x dx. And this is much simpler to integrate since we're just integrating one variable with respect to itself, right? So if we integrate this, what we get is we raise the power by 1, so it becomes u squared, and then divide that power by 2. So we've already integrated, and now what we can do is we can substitute our sine of x back into our u, right? Because that's what u is equal to. It's equal to sine x. So this becomes sine x squared all over 2. And we still must, since we're doing definite integrals, we need to evaluate this from 0 to pi. And when we do this, right, so this is just going to become here, let's see, it's going to become sine of pi squared over 2 minus sine of 0 squared. And this is where it's really nice to know your unit circle from pre-calc, so you could solve problems like this. Sine of pi is, okay, well, that's actually equal to 0. And sine of 0 is also equal to 0. So look at that. We have this complicated problem, the integral from 0 to pi of sine of x cosine dx, just to find out that its answer is 0. Let's look at another example that we can use substitution with, right? Say we have here, I'm just making this up right now. We'll use 0 and 1 as our bounds since it's super easy to work with. Say we have, we're taking the square root, right? That seems like it's difficult. And we have 3x squared, right? And then, what can we do this with? Let's say we make it minus 2x. So the square root of 3x squared minus 2x, right? And we're going to multiply this by 6x minus 2, right? dx. This, again, very complicated looking problem, but we can also notice this relationship. We can try and use u substitution, right? So what if we said that u is equal to 3x squared minus 2x? And du, right, the derivative of u is equal to 6x minus 2 dx. Well, we have everything that was in our original problem, right? So we can rewrite it now. We'll have the integral from 0 to 1 of the square root of u du. If you did not already know this, square root of u can be rewritten as u to the 1/2 power, right? So when we're integrating, we can just use the reverse power rule. So when we raise that power by 1, it becomes u to the 3/2 power. And if we divide by that new power 3/2, we can just multiply by the reciprocal, so it becomes 2/3 u to the 3/2 power. And now what we're going to do is we're going to substitute what we had for u, right? Because we said that u was 3x squared minus 2x. So this becomes 2/3. 3x squared minus 2x to the 3/2 power, right? And we need to evaluate this from 0 to 1. So when we evaluate from 0 to 1, right, this becomes, okay, it's going to become 2/3, 3 1 squared minus 2, 1 to the 3/2 power, and then subtract. When we plug in 0, it's just our answer is going to be 0, right? So minus, oh god, hold on, let me erase some of that. Okay, so this is all to the 3/2 power, and then we're going to subtract 0, so nothing happens. And when we evaluate this, let's see what we get. We get 3 minus 2 is 1. 1 to the 3/2 power is 1 times 2/3 is 2/3. So that would be our answer. And this is how we do substitution for definite integrals. If you made it to the end of this video, thank you for watching. I really appreciate it, and I hope you learned something.